In this video I will explain how to build your own production time calculator in Excel file. I use it as a quick tool for determining the number of cavities required for an injection mold, and it can be very useful for other projects as well. Before we start, I will explain the critical factors required for calculations. As you can see in this picture, in the green column is the data you and the customer must define, for example order quantity, or the estimated annual volume. This should be defined by the customer. Make sure the customer includes the maximum capacity for the tool. This can be 10 to 20% increase. It depends on the customer requirements for the quote. You may want to do a separate calculation for the increase in production time. When I build an injection mold, I make sure the number of cavities or parts per cycle can handle the estimated annual volume and the maximum capacity. More cavities save production time, however more cavities can mean more maintenance. It depends on the part complexity. For this reason you must make sure the molded part is designed for manufacturability (DFM) and for conventional tooling standards. For the defined data you must have order quantity, or estimated annual volume. Defect rate, percent most likely is 5%, however some jobs may require a higher percentage. Parts per cycle or number of cavities. Cycle time in seconds. Machine uptime, percent, or production efficiency, most likely 80 to 85%. Number of machines, or operators. Run hours per day. For the calculated data you must look for run quantity, the total number of parts that are manufactured, which may include any incomplete or defective parts. Run time in hours, the amount of time that machines are running during the manufacture of parts. Downtime in hours, the amount of time the machines are down for maintenance or other tasks. Production time in hours, the amount of time required for all machines in use to manufacture the production quantity of parts, including the runtime and downtime. Production time, days, the amount of time required for all machines in use to manufacture the production quantity of parts, including the runtime and downtime. Production rate, parts hours, the amount of non-defective parts produced by a manufacturing process in an hour. This is how I calculate cycle time. In this case experience is very important. Most likely if you have been working in the injection molding business long enough you will know the average cycle time for most materials. However, this is the scientific way for calculating the cycle time. As you can see in this picture, the typical injection molding cycle clock consists of 1 second close mold, 5 seconds fill time. This depends on the part shape, size, nominal thickness, and the variation in the part thickness, thick to thin. And vice versa, it can be longer than 5 seconds. 10 seconds pack and hold. 15 seconds part cooling. This depends on the part design, however for a start you can pick a recommended cooling time from this chart based on the molded material and the part thickness. 2 seconds for open and eject part. For this presentation, I will use PP polypropylene for the molded material, 2 mm nominal thickness. The approximated cycle time based on this available information should be 31 second cooling time plus 17 seconds. For this reason I will use 42 seconds for preliminary cycle time and 60 seconds for the preliminary quote. Notice that I have not used the exact value for the quote, I have rounded it to the higher value. For this calculation I will use 85% for machine and production efficiency. For your reference, 1 hour equals 3,600 seconds. These are the known data defined by the customer and the supplier. Estimated annual volume 2 million parts. Defect rate 5%. Part per cycle or cavitation 16. Cycle time 45 seconds. Machine efficiency 85%. Number of machines 1. Run hours per day 14. The calculated data are as follows. Run quantity, 2 million multiplied by 1.05 equals 2,100,000. Is the total number of parts that are manufactured, which include any incomplete or defective parts. Runtime hours, 3,600 seconds divided by 45 seconds, multiplied by 16 cavities equals 1,280 parts in an hour equals 2,100,000 divided by 1280 equals 1,640.625 runtime hours. Is the amount of time that machines are running during the manufacture of parts. Downtime in hours, 85% minus 100% equals 15% equals 0.15 multiplied by 1,640.625 hours equals 246.09 is the downtime in hours. Is the amount of time the machines are down for maintenance or other tasks. Production time in hours, 246.09 hours plus 1,640.625 equals 1,886.73 hours. Is the amount of time required for all machines in use to manufacture the production quantity of parts, including the runtime and downtime. Production time, days 1,886.73 divided by 14 hours equals 134.77. Is the amount of time required for all machines in use to manufacture the production quantity of parts, including the runtime and downtime. Production rate, parts in 1 hour 2 million divided by 1,886.73 equals 1,060 parts in 1 hour. THS is the amount of non-defective parts produced by a manufacturing process in an hour. I have converted these calculated values to an Excel equations. In an Excel file, please create this chart as shown below. Make sure the rows and columns are exactly matching this picture. In this green area only enter the known data. In the column named results enter these equations. Now once you have created the file as instructed in the previous slides, try to enter different known data like estimated annual value, cavitation and cycle time. You can use this calculator as a tool for your projects for defining the required cavitation for an injection mold based on the estimated annual volume and cycle time.